summary table for the ungroup data measurement. Okay. Right. So this slide actually you can get from the Canvas site. Go to modules and then choose week 3 and click on this file. All right. Yeah, this is the one. All can see, all right. I don't need to copy anything, because you can get the information from your lecture notes later on. All right, so on Monday, last Monday, a few days ago, right, during the lecture, the week 2 lecture, we already study a few measurements, right, for the ungroup data. Ungroup data means the raw data, right? So please refer to this column, all the measurements formula, all this you can refer to this column, ungroup data. At the moment, please ignore the group data formula, slightly different. We are going to cover the group data in week 3. Okay, this week I'll just focus on the ungroup data. That will be those measurements. Okay. So at first we already studied the mean, right? Mean means the average. So the formula is using the total x divided by n. Okay. Then the next measurement is mod means the most frequent occurs value or number or figure or object. Right. So in order to calculate the mod value, make sure that you have to arrange the data from lowest to highest. Okay. This is from the week 3 module lecture notes, the summary table. Okay. Then the next measurement is median. Median means the middle number, middle value. So in order to get the middle value, you need to arrange the data from smallest to highest. First step. Okay. The second step is to identify the term of the median using this formula. Using this one, n plus 1 divided by 2. Term means the location. Okay. So temporarily ignore this column. Okay. Ignore this column. We just focus on this column this week. Right. Ungroup data. So once you identify the median value using the formula of term of n plus 1 divided by 2, then you should be able to get the median value. Median value is in the middle. Okay. All right. Then the next measurement is first quartile. First quartile also called as lower quartile or 25th percentile. Okay. So in order to get the value, also the same, you need to sort the data first. Remember, sort the data from lowest to highest, and then identify the location of Q1 formula. You have to use n plus 1 divided by 4. Why divided by 4? Because 1 over 4 means 25%. Okay? 1 over 4 means 25%. That's why divided by 4. Okay? 1 quarter. Okay. The next measurement for locality measurement. Locality measurement means you can only measure the value, okay, of certain to describe the data, at certain point only, to describe the data at certain point only. So we call it as locality measurement or centrality measurement. Okay, so Q3 is also a locality measurement as well. Only can describe the data at one point. Okay, so Q3 is also called as third quartile, upper quartile, or 75th percentile. Okay, so also the same thing, you need to sort the data first step. Second step is identify the location using the formula 3 multiplied n plus 1 divided by 4. 3 over 4 is because 75%. Okay, I then calculate the Q3 value. Later on, I'm going to show you some example, using the exercises as example. Okay, so far these are the formula that you need to know for locality measurements. Okay, next we also have studied the measurement to describe the data in terms of the variability, or we call as the dispersion of the measurement, to further describe the data that we have. Okay. So for other formula that we have studied the variance. Variance, the symbol we use is s power 2. Okay, variance for simple. For the sample, we use s. Okay, s power 2. So how is the formula to calculate the variance value? We have to use the formula of 1 divided by n minus 1. N means the number of data available. So for a project, you have 50 data. You're going to collect 50 data. So n is 50. Okay, and you need to have the total x square value. Total x square value you need, and also the total x value. Okay, and then remember you have to put power 2 after replacing the total x value and divided by n. Okay, so bear in mind the variance value also always positive. As a result, the total x square value in this part, this area here, must always greater than this one, the whole thing here. Okay, this is the way you check your result. Okay, if you use total x square minus the whole thing here is negative number, that means something wrong with your workings. Okay, you better check again. Working maybe got some mistake. You have to check again. Okay. Then the next measurement is standard deviation. Standard deviation is also used to measure the average difference between the mean and observed data value. Okay, it's the average difference between the mean and observed data value. Observed data here for your case is the 50 observed data. Okay, with the mean average, with the mean difference is how much you get divided by 50 minus 1. So that will be the average difference value between the mean and observed data. Okay, so bear in mind the standard deviation also always positive. So how is the formula? In fact, the formula is using the square root of variance. Okay, square root of variance in order to get the answers. Okay, so if you want to describe further again, then we can use coefficient variation. Okay, coefficient of deviation in order to identify how varied the data distribution. How varied means how much difference, to what extent the difference of the value of the data. So the higher the CV, the higher the variation or differences of the data value. Okay, so that means if CV is very high, that means you have very extreme small number. Okay, and you have very extreme big number in your data set, and then you have very big CV. Okay, so what is the formula? Formula is using standard deviation divided by mean, and then multiply with 100%. In fact, should put percentage at the back. Okay, so simplify. Your answer can be less than 10%, can be about 50%, can be more than 100%. Okay, so bear in mind, the unit for CV is always in percentage. Okay, let's say your topic is on YouTube watching watching time, okay, of the simple student. Watching time is maybe is in hours or units or minutes, all right? But when you want to calculate the CV value, make sure that the unit is in percentage. Okay, leave the unit in percentage for CV. Okay. Okay, another issue is, in fact, the standard deviation also used to measure the dispersion of the data distribution. Okay, so now you may ask, which one is better, standard deviation or CV? Answer is CV is better. CV is better to measure dispersion of the data distribution. Okay, it's better. Why? Because CV also taking into consideration of the mean difference. Okay, mean difference. Yeah. So if two set of data have different mean value, then you should not use the standard deviation to do comparison. You should use the CV when two set of data have different mean value. Okay, then the last measurement is called as skewness. Skewness of SKP is used to identify the pattern of the data distribution, pattern or the trend of the data distribution, whether it's symmetrical, skewed to the left, skewed to the right. Okay, you can use histogram, you can use polygon to identify the shape of the data distribution. If you cannot really identify, not sure, then what can you do is you can use formula. Okay, so far we have learned two formula to identify the skewness of the data distribution. So the first formula is using the mean minus mod divided by standard deviation. All right. If you don't have mod value, let's say if your data have no mod, then what you do is you can use the second formula, 3 then brackets multiply mean minus median divided by standard deviation. Okay. Okay. Another issue is sometimes the question may not give you the standard deviation. Sometimes the question does not have standard deviation. Then what can we do? You still can identify the SKP. You still can. Why? Because the standard deviation value is always positive. We know that it's always positive. Okay, we assume that it's always positive. So even though we don't have the figure, we still can identify the skewness. Right? So if the SKP value, we can use the mean minus mod. If the SKP value is equal to 0, that means the mean is equal to mod, equal to median exactly, yeah, that means SKP is 0, then we can conclude the data distribution is symmetrical. Okay, so please add one more word here, data distribution, okay, is symmetrical. What happens if the SKP is greater than 0, that means positive. So you can conclude data distribution is skewed to the right or positively skewed. Okay. And lastly, if the SKP is negative number, that means less than 0, that means the data distribution is skewed to the left or negatively skewed. Besides this measurement, we also learned the range and interquartile range. Remember, range and interquartile range. Do you know the formula for range? I don't put here, huh? Range, the formula is, what is the formula? Can you recall? Range, R-A-N-G-E. Pardon? Yes, correct. So using the biggest value from the data minus the smallest value of the data. Yeah? Then how about interquartile range? Can you recall the formula? Interquartile range. Q3 minus Q1. Okay, correct. Thank you. Okay. So these two formula I do not put here, so you have to recall. All right. Okay, besides knowing how to calculate all these measurements, you must also know how to interpret the value that you obtain for each measurement also. All right, so because this will be, you may need this knowledge for your project 1 later on, and also project 2. Okay. So for mean, so how to describe the mean value then? Okay, you can, the keyword is, you should use the word like average, the keyword. Okay, you can say on average, this one for this question now is about the test mark of the student. So on average, each student score 88 marks in the mathematics subject, for instance, okay, or in the mathematics test. Okay, mod, you have to use the word like most of the or majority. Okay, majority. If you don't want to use most of the, you can say majority of the. Okay, of the students, in this case, of the students managed to get 88 marks in the mathematics test. Okay. Median, how to describe median then? The median value, you can say 50%, always start with 50% of the study object, okay, obtain more than certain, or more than the median value, okay, and the remaining 50% are obtained less than the median value. Okay, Q1 we always start with 25%, okay? Because 1 quarter, so we start with 25%. 25% of the study object obtain more than the Q1 value. Okay, and the remaining 75% of the study object or the paper, okay, obtain less than the Q1 value. Okay, so for this one, you need to put the Q1 value here, substitute the Q1 value to these two. Okay, and then how about Q3? Q3, you start with 75%, okay, of the observed object obtain less than the Q3 value, and 35% of the study object get more than the Q3 value. Okay, so I already list down the sentence you can refer for your project 2 later on. Okay, how about standard deviation? Standard deviation is actually the average difference value between the mean and observed data. Okay, it's the average difference value between the mean and observed data. So if your standard deviation is 88, then just put 88 marks. So bear in mind, you have to leave the unit. The unit for each measurement, you have to put the unit. Okay. For CV, it's percentage. And then for skewness, there is no unit. Okay. Skewness has no unit. Skewness only tell you the magnitude, whether it's 0 or negative or positive. So for CV, okay. So that means the higher the CV, the more disparate is the data distribution. Disparate means more varied. Is the data distribution. Okay, so the opposite of dispersion means consistent. Opposite of dispersion means consistent or stable. All right, so these are the measurement that we already studied during the lecture on Monday. I stopped for a while. Any questions so far? Make sure that you're okay with ungroup data, because coming week we are going to group data, and the formula to calculate the measurement can be slightly different. Okay. Okay, if not, then we'll move on to the exercises. All right, tutorial exercises. We'll focus on exercise 1.7 and 1.11 for this week. All right, 1.7 to 1.11. Okay, yesterday I already shared the amended tutorial questions. Maybe I can open. Okay, I already shared the tutorial questions through announcement yesterday. The file that I provide to you is in the Microsoft Word file. The reason is because so that it's easy for you to copy the data from the tutorial exercise and paste to the Excel. Otherwise, you need to type, time consuming. Okay, so the tutorial question file is in the Word form. Okay, you can open and have a look. It's under here, under announcement. You can go to announcement. Yeah, this is the one. Okay. Probably we can go through a few questions, all right, to discuss that. After that, I'll let you do the exercises by yourself. Okay. We can pick a few questions to do. Okay, 1.7, here, this page. Okay, I probably can demonstrate to you how to do shortcut. Okay, using Excel in order to calculate all the measurements besides using formula. Any other method we can use. Okay, you may find that for question 1, exercise 1.7, there are many data altogether. We have 41 data. Okay, question 1, exercise 1.7. Let's say for this question, we have 41 data. A lot. Okay, so in order to save the time, I'll just copy this data, all right, from Microsoft Word. I copy. Okay. Then I open one Excel file because I want to save the time. Okay, I try to get one Excel file. As long I have to wait for a while. Okay. Yes. I try to increase the size so that you can see. Okay, so probably I just simply paste the number into the Excel. Let's say I simply choose one cell. You may also simply choose one cell. Let's say I choose this one, and then I choose this paste. All right. Okay. In the Excel, if you want to measure all this data distribution, all this, you need to arrange the data in the vertical form. Vertical means you have to arrange the data from top to the bottom. Otherwise, the Excel cannot read, cannot understand. That's the problem for Excel. So we need to arrange the data in the vertical form. So now it's in the horizontal form. Okay, so how to arrange the data in the vertical form? Okay, I'll start from the first row. Row number 1, I just highlight, copy. Then I just put maybe here, right? A1. Okay, when I paste, I should use this one, transpose. Okay, then do for row number 2. B. Go to here, then paste. So continue the same process for row 3. paste using transpose. Okay, there is one number here, which is 9. Okay, I just start in order to set the time. 9. Right. So altogether, how many data? 36 data only. 36 data. Suppose should have 41. Should have 41 data. Okay, let me copy one more time. Copy and paste again. Okay, 9. 41. Okay. If you want to know whether it's 41 or not, usually I will refer to here. Otherwise, you can do counting. Do counting. Okay, I try to increase the screen size so they can see the whole picture. Okay, so if you want to know how many data you have, you can do counting. C-O-U-N-T. Okay, counting. Count, usually I use equal C-O-U-N-T. Okay, to count how many data we have copied, right? So highlight. All right, then put a cross bracket, and press enter. Altogether, we have 41 data. Okay. Okay, I'd like to show you just a shortcut to check your answer by using Excel. But in the project, you still have to use formula to do the calculation for mean. Okay, mean. I put somewhere here, mean and okay. How to calculate the mean value using the Excel? I'd like to show you. Okay, so in the Excel, you cannot find the mean function in the Excel, but you can get a function of average. You can type AVERAGE. Okay, when you type AVE, right, then there are many options for you to choose. So you choose average, this one. Second one, I try to increase the size of the screen. Okay, increase the size. Okay, so how is the formula can we use in Excel? Equal average AVERAGE, this one. The second one, right? So if you want this function, then you can double click using the left mouse, double click this function. Then you should be able to, find the equation now. Okay, you have to ask to add the numbers in. You have to select what are the data you have. So we need to select this 41 data. Until here, until 9, right? Then put a close bracket. You have to press shift button at the same time. Put the close bracket, shift and then the close bracket function. Okay, then press enter. So answer is about 5.37. Okay, you can round the answer to 2 decimal places. Round to 2 decimal places. So how to do so? Okay, you can go back to the cell again. Right, then you go to the top of the Excel file. You choose this one. Okay, decrease the decimal. Okay, just click on the icon until you manage to get 2 decimal places number. Okay, mean value. Okay, average. Okay, next measure is mod, right? Mod. We know that sometimes the data may have more than one mod, may have more than one mod. So if there's a case, when we choose the function, we may need to ask for multiple mod function just in case, all right? So, okay, when you type mod, right, you may find that there are many options for you to choose, okay? This one is multiple mod, okay? This one is single mod. If you choose single mod, that means the Excel will find the mod with the lowest number, the lowest value figure will be given to you. If you choose multiple mod, then more than one mod of the figures will be given. If there are two mods, okay? So if that's the case, we'll choose multiple. We'll choose multiple. Okay, choose this one, the first one, multiple. So double click on this function 2 times by left click the mouse. Right, then you highlight or select the cell of the 41 data. Okay, then put a close bracket. So that means 2 occurs most of the time. 2 appears most of the time as compared to other figures. Okay. Then the next one is median. Median. So in Excel, you can just type equal median, MEDIAN. Then this function appear. So click on this function 2 times. Left click 2 times. Right. Then highlight or select the 41 data. Make sure that the data already arranged in the vertical form, top down, okay, top down form, and must be sorted. The data must be sorted. Have we sorted the data? Not yet. So okay, we need to sort the data. All right, so this one I cancel. Because if you don't sort the data, then you're not able to get the correct median value. So we need to sort the data first. We haven't sorted the data yet. Okay, so highlight this 41 data, go to data tab, okay. Then choose this one, A to Z. Oh. Continue with this, okay, current selection. All right, so let us try. Okay, now median equal median. So it's 5. Okay, so the middle number of this 41 cell data is 5. So that means 5 is in the middle location among this 41 data. Okay, so far so good. Okay, next, okay, I'm not going to show you the shortcut for Q1 and Q3 because the problem is in the Excel, there are 2 types of way to identify or calculate the Q1, but I can show you, okay? You can use the percentile. If you type percentile, you may find that we have this exclude and include, okay? There are 2 ways, so I'm not going to show you. I'd like you to just use manual method to calculate the Q1 and Q3 using the manual method, okay? Instead of using the Excel. Okay, then next measurement will be variance, variance. If you refer to your project, right, you are going to collect 50 data, right? So these 50 data are considered as sample, 50 sample. Why only sample? Because you only collect partial of the data from the whole population. Let's say if your study is on YouTube watching time among the Swinburne Sarawak students, if this is your topic, so that means your population for this study will be all of the Swinburne Sarawak students, which consists of 3,500 students maybe population. But because of we want to save the time, And we are not able to also reach all of the 3,500 students, so we only select 50 data. So these 50 data are considered as samples. Okay, so if you, that means we are going to use sampling as measurement. Okay, sampling measurement only. So if sampling, okay, then when we calculate the variance, then the formula is slightly different. We already learned, in fact, on Monday, I already learned. But in the Excel, you may find that when you type variance, VAR, AANCE, let's say, variance, type one more time. I think it's VAR. Okay, VAR. Okay, VAR. For variance using the formula of VAR, you may find that there are many options for you to choose. We have VAR.P, VAR.S, VAR, a lot, right? Okay, what's the meaning of P here? P is stand for population. If your data are collected from these 3,500 students, then you can use this formula, population. But if you only select a few samples, okay, for measuring the variance value, then we should not use this formula. Okay, how about this one, the second one? Second one, you got VAR.S. S means sample. Sample. So we should use the second one. Okay, sample. So it depends on the data that you have. If you only collect data from partial, okay, of the population, or we call it sample only, then you should use this one. Second one. Okay. Then highlight the 41 data you have. Right, then put a close bracket. So let's go to 16.04 if you round to 2 decimal places. Okay, usually we round to 2 decimal places. You can go to Home tab and click on this button two times or 3 times. So far so good. So some students may ask, then what is the difference between the population and the sample formula for variance? The difference is here. So some of you may have a doubt then. Therefore, is the formula, the difference, okay, for the population and the sample, is here, this part here. Okay. For sample, the variance formula is using 1 divided by n minus 1, minus 1. Okay, minus 1. But for population is without minus 1, just off. This is the only difference. If minus 1, that is for sample. Okay. For population, this one doesn't have. No need to minus 1 for population. You may ask, what's the reason we want to minus 1? Why the statistician would like to minus 1? It's because if the sample size is small, then your data distribution usually is not normal. Okay, so in order to address the sampling error, the statistician suggests to put minus 1 when we want to calculate the variance for sample. Okay. So far so good. Okay, then how about standard deviation? In order to save the time, I just simply use shortcut. I use the short form as well. Standard deviation. Okay, so what's the formula that you can use to check your answer? But in the project, you still have to show workings, right? This one is only for you to check your answer. Okay, go to equal, go to STD EV. Can you see STD EV? There are many options also. We have .P, .S. So we should choose .S, sample only. Okay. Left click the mouse 2 times by pointing to this function. Right, then highlight this 41 data. Okay, and then you may round the answer to 2 decimal places. Okay, so it's about 4.0. Okay. Okay. Then how about range? Interquartile range, CV, skewness. All this you need to calculate manually. Okay, you need to calculate manually. There is no shortcut from the Excel that can help you. But I'm not going to teach you. Okay, you'll learn this one in your degree, right? I just want you to learn manually. All right. So what's the formula you can use to calculate the range? Just now I think some student already mentioned that the range. I think here also have the formula to get the range. Let me see. RANGE. Okay, it's so easy, yeah, because range is using the highest number minus the lowest number. So it's easy, yeah, right? So you just need to make sure that you sort the data, yeah. So in this case, 11 is the highest number, right? And then minus the lowest number is 1. Okay, so you get 10. There is the difference between the highest and the lowest number. Interquartile range, before we can get the interquartile range, we need to get the Q3 and also Q1, huh? So that we can get the interquartile range. Okay, we'll do the calculation manually. Okay, I'll show you the manual method for calculating the Q1 and Q3. Maybe I'll just put somewhere here, right? Okay. Okay, in order to get the Q1, make sure that you already sort the data in Excel from smallest to highest. Okay. Then the next step is to identify the location of Q1. Location means the term, all right? What is the formula? You have to use term of, I put bracket, n plus 1 divided by 4. Okay. So we use this formula to identify the location only. Location, not the value, but the location only. All right. Then the next step is to substitute the n value into the formula of term. Okay. I should put equal sign, but because of Excel, so yeah, I skip that one. Suppose I have to put an equal sign. So n in this case is 41, right? 41 data plus 1. Right? So in fact, it's at the location. 41 plus 1 is 42, right? 42 divided by 4. 42 divided by 4. Let's check what is the answer. 42 divided by 4. 10.5. Term of 10.5. Okay. If 10.5, that means it's exactly in between term 10 and term 11. Exactly in between term 10 and 11. If that's the case, we can just get the average value between term 10 and term 11 directly, right? Directly, we can get the answer. Okay, so which one is term 10? Which one is term 11? Term 10 is this number. I use red color, right? This is term 10. This is the location of term 10. All right. Location of term 11 is also 2. Incidentally, also 2. So I use purple color. All right. So that means term 10 and term 11, no difference. No difference. So 2 plus 2 is divided by 2. You'll get 2. Exactly equal to 2. Answer is equal to 2. Okay. Okay. If you don't want this answer directly, okay, I'll show you the longer method. So answer actually is equal to 2, because we know this 2 is direct 2, term 10. This is a longer way, okay, plus the purple 2. You get a difference for purple minus the red 2. This is a longer way, right? And then multiply with 0.5. 0.5 is from here, from this part, 0.5. So we know that, right? 2 minus 2 is equal to 0. 0 multiplied 0.5 is 0 also. So 2 plus 0, 2 plus this part, the whole thing is 0. So you get 2 positive. Okay. Answer is 2. Okay. Then how about Q3? Q3, okay, also using the same methods. I copy this to here, let's say. Okay, so what can we do is just need to change 1 to 3. This one, put 3. This one put 3, multiply 3. P5. 3 multiply 10.5. What is the value? E multiply. Up. Multiply have to use the symbol of 10.5. 3 multiply 10.5. Let me see my multiplication symbol. 31.5. Okay. This is the location of your Q3, 31.5. So that means it's in between term 31 and 32. Term 31 and 32. Okay, let's go to check where is the location of term 31. Here. Okay. This is the value of term 31. 9. 9 is the value of term 31. Term 32 is 10. So I use purple color. Okay. Right. So how to get the Q3 value? I'll show you manually. Okay, term 31 is 9. This is 9. Right? Term 32 is 10. The difference now is 0.5 also. Okay, I use black color so that you know this is from from this part. Okay, 0.5. This one also 0.5. I put black color. Okay, so let's try to simplify this expression. 10 minus 9 is 1. 1 multiplied 0.5 is 0.5. So 9 plus 0.5. This part whole thing is 0.5. So 9 plus 0.5 is 9.5. So once you know the Q1 and Q3 value, you can put these two numbers for calculating the interquartile range. So I'll put the formula somewhere. And where are the workings now? The workings for just now the answer, interquartile range. Okay. Okay, add one more row. Interquartile range. I'll just put IQR. Okay, IQR. So the formula is equal to Q3. Just now Q3, what is the value? Okay, I go out again. Q3 is this number. Minus the Q1. Q1 is 2. Okay. 9.5 minus 2, you'll get 7.5. So always using the upper number minus the lower number. Using the Q3 minus Q1. Okay, next measurement will be the CV. All right, CV, I use CV and coefficient of variation. Okay, so what is the formula to calculate the CV value? You have to use the formula of standard deviation divided by mean. So formula is standard deviation divided by the mean value, this one. Okay. Okay. But because we want to round the answer to 2 decimal places, to percentage as well, to percentage. So if you want to convert this number to percentage, there are many ways. You can either multiply 100 directly, or you can use this function to change this value into percentage units. Okay, so you can use this function if you want. Okay, press this function so they can change to percentage. If you want to round the answer to 2 decimal places, then just go for this. Okay, press this 2 times. So it's 74.63%, very high, very high. So that means the data distribution of the of this data highly dispersed. Okay, highly dispersed. Okay, lastly, skewness. Skewness is SKP. I use shortcut SKP. But in your project, you have to write down full term. SKP. Okay, there are few formula that we already learned. I prefer to use the first one, easier. Okay, shorter also. So the formula is using the mean. Mean is this number, right? Minus the mod, this number. Okay, divided by the standard deviation. Okay, in order to differentiate the numerator, so usually I like to put brackets aside the numerator. Okay, then divided by the denominator. In this case, is the standard deviation. This one. So bear in mind there is no unit for SKP. Yeah. So answer is about 0.84. Okay, positive. So that means the data distribution is skewed to the right. Okay, for this question. All right. So yeah, done already. So these are the shortcuts that you can use to consider when you want to do your project or your tutorial exercise. Probably you can consider to use all these Excel formula. But for your project, you need to present your answer, everything nicely using manual method. You have to show the workings. I'm going to share with you the presentation of the project one later on by sharing the sample from the previous semester, probably during the next tutorial. Okay. Now it's already 10 o'clock. Nearly 10 o'clock. Do you have any question before I let you do the tutorial exercise by yourself, and then I'll just walk through and check your work. Okay. Then okay, free time. I just let you do the tutorial question. Okay, if you want to go to toilet, go to eat. Okay, go ahead. Free time now. Okay, you can do your own work. You can start now if you want. All right. So for the online student, also the same. Let me see. Okay, so for the online student, also the same. Now I have covered the summary for ungroup data measurement. I'll let the students to have the free time to do the tutorial exercise. So you can start with tutorial exercise 1.7 to 1.11. If you got any problem, you may ask question. Either you can type in the meeting chat or you can just mute your mic, okay, and unmute your mic so that you can ask question if you want. So today we have Jasmine, Wei Fen, Tri Eng, and Darian, okay, joining the online session. Yeah, Darian, okay, good day, good day. Okay, we may want to see your students, okay, the class situation, classroom, like this. Okay, let me try to put. I think for your project, most of you already found the groups, like most of you already found the groups. That I think this morning when I checked, probably a few groups can take attendance before the project. So sign your name with this folder. This is the Microsoft Word. Yeah, you can do exercise 1.7 to 1.1. Yes. how to get this value. Total exit data. Okay. Okay. So class, okay. If you want to calculate the standard deviation manually by using formula, and is there any shortcut? If you want to calculate the standard deviation manually, okay, I'll use the same example. Just now the same data, 41 data. Yeah. If you want to calculate manually, okay, without using the Excel formula, is there any shortcut? Okay. Okay, now let me go back to here again. So we know that, okay, the standard deviation formula is this one, right? This is the formula that we already learned, okay, to calculate the standard deviation manually, manual one. So in order to get the standard deviation, there are two things that are very important. You need to calculate the total x square value and also the total x. These two are very important. Yeah. So if you want to save the time, you can try to calculate separately for these two variables. Okay, total x and total x square. Yeah? Okay. Okay, we know that these are the 41 data. I use another sheet so that you are not confused. Let's say, okay, we already have the 41 data. I try to increase the size. I try to add one more row here, insert one more row. And this row actually is called as X. Okay. All these 41 data all are called as X. X. Okay, I add one more column here. Okay. I bought it, okay, and I centralize. I center. So if you want to calculate the total X value, how to do so? You can use sum. If you want to save your time, I put total or I put sum, same meaning. Total means sum. So if you want to calculate the total X value, how? What can you do is you can use SUM formula, SUM, right? Then double click, left click this function two times, right? Then highlight the 41 data. Then put a cross bracket. So 220 is referred to this. 220 is referred to this one, this part. Okay, here. The number inside the brackets, that is 220. Okay, maybe I borrow it. Okay, then how about this one? X square. X square, how to get the answer? X square, okay, I can add one more column if I want, so that I can set the time. Because there is no superscript function, I just simply use this, triangle 2, means power 2, right? So if I want to get x power 2, how? Okay, I have to square all of the x value. So the first number is this one, right? 1 multiply 1 again, right? Okay, and then multiply this again. So 1 multiply 1, you'll get this, right? So let's say for this figure also the same, I have to use 2, then multiply the same figure again, right? Continue, but there are so many data, right? So is there any shortcut? Yes. What can you do is you can, since the first cell we already created the formula, right, for this cell. So you can just copy the formula, the same formula for the remaining cell as well. So how? Okay, you have to move your mouse cursor to the bottom right-hand side of the cell, of this cell. You have to move your mouse cursor to the bottom right-hand side of the cell until you can see a black cross sign. And okay, then you need to left click the mouse by pointing to this corner and then drag the mouse down until the last data. Release the mouse. Okay, right? So this will help you to calculate all the x square value for all of the data. X square. Right? Okay, so how to get the total x square value? Because just now I have copied. Okay, there are two ways. You can simply use SUM. Right? Then highlight the 41 data. It's 1822. So 1822 is referred to this part. Yeah, okay, 1822. Yeah. Okay. So let us try to use formula manually to calculate the answer now. Okay, let me see whether I have the formula that I can copy directly or not. Otherwise, we need to create the formula by ourselves. Okay, if that is the case, I'll just simply create one more formula, One formula, okay, standard deviation. I use shortcut, maybe I type properly. The formula is equal to insert equation. Okay, then I can go to design equation. Okay, equation. Okay, I type now. Equal. Okay, I should choose the square root, this one. Okay, got two layers, one divided by. So I choose this one, fraction. And then we have a big open bracket. There are many ways. I can also choose the open bracket using this function here. This one, okay? Okay, the first variable is total x squared. I choose this one, right? And for this, I'll put power 2, so I need this. This one. And the next variable is minus. Got two layers, so I have to use fraction. For this numerator, we have to put bracket and also power 2. So I will use this. To increase the size of the screen so that you can see. All right, so this is the formula for standard deviation. Okay, next step is to substitute the number into each variable. Okay, and for this question, we have 41 data, so substitute 41. This part, total x squared, just now when we use Excel, we already have the answer, 1822. How about this part? Yeah, got two layers, fraction. Okay, fraction, so I'll create this two layers for this part, for this term. Okay. Okay. Before that, I need to include the power 2 as well. This is power 2, all right? So how about here, the total x? What is the figure that we need to put? You already have the answer, which is this one, 220. Yeah, this one. Put here, 220. Remember, you have to put power 2. After the 220, you need to put power 2. Okay, it's from the formula itself. N is 41 data. Okay, so next step is to simplify this equation. Okay, 41 minus 1 is 40. Okay, 1822, I'll just leave it there, okay, and then simplify this part. Or maybe you can just simplify directly here. 220 power 2, then divided by 41. So continue the same process, or maybe you want me to show the workings. You can either use calculator to help you to calculate this part, simplify. So this area is equal to 1180.49, which is less than 1822. Yes, okay, logic. Yeah. This area is 1180.49. Okay, and the total x squared is 1822. Okay, so it's logic because this value, the whole value here is less than 1822. Logic. Okay, now I want to get the difference. So I use 1822 minus this one. Difference between this is 600 plus 641.551. So now I want to get divided by 40. You'll get about 16.04. Let's square root the whole thing. 16.04 is the number inside here. This part, the whole thing here is 16.04. Okay, I insert the square root again. Square root the whole thing. You can use Excel to help you, or you can use calculator. So equal to square root SQRT, square root SQRT. Then choose this one, put cross bracket. Answer is about 4.00. You can adjust also the location of all this. I use justification. I usually put to left hand side. Okay. The good one, yes. Only the first two. Only for that what is all that? So for the project one, question three only. And this is okay. How is your original class interval you use? The original class interval for your own class interval. The original one. This is the one original. How about this one we call as the class limit, the class limit that you use, the initial class limit for the first class, second class. Before you change to class bounding class, right? So how about your middle class? Right? This is the bounding class, right? Okay, not issue. Should be okay, should be fine. Acceptable. Can. Yeah, I think for this answer is start from 201. This is also okay. Okay, can acceptable. Pardon? Oh, okay. This is question 1. Okay, 1.6. For frequency table, if you want to construct the frequency table, there are a few steps involved. Okay, that depends on the question. Okay, if your frequency table is in the single score, it's okay, easier. But if the numbers now are highly varied, then when you want to form the frequency table, you should classify all this data into a class interval. Okay, what do you mean by class interval? Okay, let me go back to the week 1 lecture again. The lecture slide. I go to the week 1 lecture slide. Okay, you can refer to the slide whereby show you the workings on how to identify number of classes require, number of the class size. Okay, there's one question. This one, I think. Okay, this example show you the steps to form the frequency distribution table in the class interval format. So let's say we have 40 data now, 40 data. Yeah? This is the weekly sales data. Let's say we have 40 data for this question, 40 data. All right. So before you can draw histogram, polygon, or object curve, the first step is you must form a frequency table. Even for your project, question number 3, project 1, question number 3, also you need the knowledge to form the frequency table in the class interval form. Okay, so there are a few steps involved. So you can follow this. Okay, step 1 is you need to roughly identify. You have to plan. How many classes do you need? Okay, that means how many classes do you need to divide all this data that you have? Let's say we have 40 data. So what is the formula to identify roughly the number of classes? You can use the formula of log n divided by log 2. Okay, log 2 is a constant number from this formula, right? So only log n that you need to be considered here. N is referred to number of data available. So for this question, there are 40 data. So we substitute 40 to here. Right? This is from the week 1 lecture notes. Then you use log 40 divided by log 2. Answer is about 5.32. What's the meaning? So in order to classify this 40 data, you need about 5 to 6 classes. That's the meaning. 5 to 6 classes, roughly. You can either use 5 or either use 6. Some students may ask, can we use 7? Also okay, acceptable. Okay, because this formula only gives you some idea. How many classes do you need? Okay, So if you use 7, also not really wrong also. Yeah. But try not to use too many classes. Then it's very hard for you to do analysis. Okay. The idea would be like 5, 6, 7. First step. Okay. Second step is to identify the class size. Class size means class width. Means how many numbers should be included in one class. In one class, how many numbers should be included? Should be grouped in one class. That's the meaning. Class size. Okay. So what is the formula? Formula is using the highest value from the data minus the lowest value from the data, then divided by k. K means the number of classes that you want. Number of classes that you want. Okay, highest number. How to get the highest value from this question? Okay, so you have to go back to your raw data again. You check from this 40 data, which data has the highest value? Answer is 89. 89. Okay. The lowest value data is 44. This one. Okay. Right. So you substitute the 89 and 44 into the formula of class size. Okay. Then K depends on you. You may use 5, you may use 6. You need to do trial and error. Okay. Either 5, 6, or 7. Let's say now we use 6. Okay. Let's say we use 6. So if you use 6, you may find that the suggested class size is about 7.5. So it's about 8 numbers. 8 numbers in one class. Okay, that's the meaning. 8 numbers in one class. So you may follow the suggestion using 8 numbers in one class, but because I feel like, okay, if I use 8 numbers, then it's not so efficient for me to do analysis later on. Okay, when I want to write a report, I feel like it's hard to describe. So I like to use 10. I like to use 10 numbers in one class. Okay, I think the ideal one class would be like 4, 5, 10, 20, 30, 50, 100. This type of class size. 8 also okay, but in this case, I like to use 10. I try 10 numbers in one class. Right? Okay, if we decide to use 10 numbers in one class, then for the first class, which numbers will we start? You may find that the lowest number is 44 from the data set. So you can start from 44 if you want, okay? Or 41, okay? But I'll start from 40. Depends, you can start from 40, 41. Just I think some students also ask, can we start from 41? Okay, can also if you want. You can start from 41. Okay, I'll start from 40 to 49 because I want all of the second digit that started with 4, okay, will be in one class, so that it's easy to do analysis. So this one is depends on experience also. So any numbers started from 4 will be class 1. I want to do it this way. Okay. If you start from 41, then that means you have 10 until 50. Also okay. Nothing wrong also. So in order to maintain the consistent class size, so the second class should be also 10 numbers in the second class size. So it should be 50 to 50. Continue the same process until you're able to cover the highest value, which is 89. The highest number is 89, right? So I just stop until here. If you have higher number, then you can add one more class, which is 90 to 91. Okay. So this column is called as the class column. Okay, it's the X column. The first column is called as the class column or the X column. X. All right. So now we need to move on to the frequency column, which is the second column. So in this case, the frequency column is called as number of weeks. Depends on the question. For this question, the frequency is referred to number of weeks. So this is the frequency column we need. Okay. So how to calculate the frequency value for each class? Okay, for the first class, you need to check how many numbers are we in 40 to 49. You have to go back to your raw data again. It's good that you can sort the data, and then you check, okay, among these 40 numbers, okay, which numbers, how many numbers are we in 40 to 49? Okay. So altogether we have 10. 10 data are in this data range. Okay, continue the same process until you manage to find out the frequency for the last class. All right. Then you total out also the total frequency, yeah, so that to confirm there is no data missing or miscount the data. So altogether we have 50 data. And this whole table is called as frequency table. Yeah, frequency table. So you need this table for your project 1, question number 3. All right. So in your project 2 later on, make sure that when you want to calculate the mean, mode, median, or the standard deviation later on for your project 2, yeah, make sure that you need to change all these, okay, class interval into class boundary. That will be for your project 2. And you need to change this to class boundary for your project 2. Or when you want to draw the histogram, polygon, and all that. Why? Because now you may find that there is a gap in between the upper value of the first class and lower value of the second class. Got a gap. A gap is 49.1 until 49.9. Right? So that one will be for your project 2. Project 2 you need to adjust. Okay, let me do the question by yourself now. We'll try to end the session by 10:45 so that you can have time to rest and move over to another class. We'll finish at 10:45. The project. Who else haven't formed your team for your project 1? Who else? So far, we already have 3 teams, so we still need 3 more teams in that. We should expect 6 teams from this group. Let me check the latest information from the Canvas. Okay, for those who have decided the survey topic and also your group members, you can just go to the discussion. Okay, go to the Canvas site for this unit. Go to discussions. Okay, then you can go to the fieldwork project team formation. I think there are seven groups already formed. New one, latest. Okay, let me see who are they. So some students are very creative. They use this platform to collect data also. They create the Google form and collect data through this channel. Also okay, right? As long as able to collect 50 data. Some also use this channel to find their team members. Yeah. Because a quite number of students are doing online, so I have created the Microsoft Teams meeting link. This is not compulsory, just as a channel. This is only additional channel for students to have a meeting to discuss the fieldwork project. If you want me to go in for consultation, I can also join. Okay, not compulsory have to use this meeting link. You see, somebody already want to join the group. Okay, good. Ashini. You are group 3, right? Now, Jasmine, I think Jasmine, Charlene, and Defi have 3 members. You can add some more members if you want. Okay. Any students interested, maybe can join Jasmine group. Still have 2 more empty slots for Jasmine group. Waking means, what do you mean by waking time? You mean the wake up time? What is the meaning of waking here? Jasmine from group 3, right? Jasmine not here. Jasmine maybe online or is doing online. Okay, let me see Jasmine answer. Waking time. What is the meaning of waking time? Oh, wake up time. Wake up time. But how How to measure wake up time? Oh, yes, 7, okay, 7 o'clock. Let me check. Oh, wake up time, wake up time. Okay. So make sure that you are able to calculate like mean, not median for this wake up time, for Jasmine group. What is the unit you are going to use then? Minutes or hour? Jasmine, you have to check whether this topic you need to check the whether you can calculate all these measurements, whether it's in minutes or in hours. Okay, you have to decide the unit of measurement. How about Priestley group? Priestley is not in this group. Adeline Chong, Christina King, Okay, for Christina, Ryan group also, you better check again. Okay. This one, is that refer to the daily drinking water, or is that every day or weekly, or how? You need to specify in your topic. Bought by Swinburne Sarawak students daily, maybe. Bought by Swinburne Sarawak students daily. Maybe you can edit, try to refresh again the sentence of the survey question. Okay, by Swinburne students, Swinburne Sarawak students daily. Okay, for this Adeline, Christina group, Ryan's group. So we already have two more groups being formed. So that means we need one more team. So maybe the remaining student will be one team. Those who haven't found the group. Formula. Oh, you mean the reason? Oh, I think I haven't posted yet. Because I think yes, no, not I still haven't yes. Which one? You use the manual method, right? You use the formula. I use manual method. Okay. For one exercise 1.9, Okay. What else? Can you 2B, standard deviation, Okay, all right. Okay. Any more? Okay, so some okay, the student found that the answer at the back for exercise 1.9 and 1.10, the standard deviation value is slightly different. Probably we can check again. For exercise 1.9, 1.10, some of the answer for standard deviation are not so similar to your answer, right? D, question D, just now, What? Okay, let's check, So I copy this data. Go to Excel. I try to solve the data also. And try to get the standard deviation. Highlight this data. It's go to 13.94. Okay, let's try to do manually. Then, okay, this is the answer using the Excel. Then we try to do manually. 18.94. Where is the mistake? Oh, okay, all right. Data different, Oh, okay, two different data, use the Microsoft Word data, all right. So I just simply use the Excel to check the answer, all right. So it's this number. Oh, because I think too many already, too long. These are the data. I think, okay, I think it will increase the width of each cell. Okay, so it's highlight column, this column and two. Yeah. Also the same. Okay, yeah. Yes, correct. I think, just mean, right? Yeah. Average time taken by swimmer students to get ready in the morning, to get ready to the class in the morning, to get ready in the class. Yeah, I think this topic is more easy to measure, the mean mode median instead of the wake up time. Okay. So for your project, who else haven't formed the group yet?
Maybe you can form group. Okay, one. Who else are two? Three, four, five. Maybe five. You can be in one group. Is that okay? That is the remaining student. So one, right? One, two, three, four, five. Right. So five of you in one group. Last group. It's okay. Right. That will be team number 6. 3F. This is 3F.
Okay, so the team leader, please try to, after you have discussed the topic, finalize the topic of your survey, please go to Canvas site and key in the details of your group members and also the survey. You should describe the skillness of the data distribution. Related to the level of skill. Yeah. It is a need for multiple. Yeah. Normally, I know we don't use this distributed. Distributed. The term that's not. That's right. So this skillness formula is used to identify the pattern of the data distribution. Okay, how does the data looks like? Yeah. So generally, we have studied 3 patterns of the data distribution, the trend of the data being distributed. Right. So if you can go back to your PowerPoint slide. Let's say, let me see whether I have the slide or not. Okay, I have to go back to your week 2, week 2 PowerPoint slide. Okay, I try to get the week 2 PowerPoint slide now. Week 2 PowerPoint slide. Okay, I use this one, all right? Okay, so there are two ways to identify the skewness of the data distribution. You can either use formula or you can use the polygon or histogram, the diagram to help you to identify. All right. Okay, if the formula that you use is this one, right? Let's say mean minus mod divided by standard deviation. If the value that you get is equal to 0 exactly, if your SKP is equal to 0, so that means the mean equal to mod and is equal to the median. As a result, your SKP is 0. Okay, then what is the meaning? What is the meaning of SKP 0? That means the data distribution is symmetrical. Symmetrical, that means the data distribution will be a bell-shaped curve. Okay, whereby the left-hand side of the area is exactly equal to the right-hand side of the area. Symmetrical. Left-hand side is equal to the right-hand side. And it's a bell shape. Okay, second scenario of skewness is if you use this formula to calculate the SKP, let's say you get positive number greater than 0. What's the meaning? That means the data distribution is skewed to the right or positively skewed. What's the meaning? You may find that the data distribution is skewed to the right hand side, whereby the tail is on the right hand side. Okay, tail is here. It's skewed to the right. Okay, we always look at the tail. And this is the tail area. Okay, skewed to the right. If the SKP is greater than 0, that means positive. If your SKP is negative number, that means the data distribution is skewed to the left. So that means the tail of the distribution is on the left hand side, which is here. So hopefully you can understand the concept of skewness. Yeah, using this PowerPoint slide. Okay, so it's already 10:45. I believe you need some time, right, to move over to another class. Yeah, I'll see you on coming Monday. Monday we'll go for the part 3 of chapter 1. That will be the last part for chapter 1. Okay. So I have to end the session now. For the online students, okay, we need to end the session now. I will stop the recording and pause the recording on the Canvas later.